All right, so yeah, today I wanted to talk about impl in type aliases. It's a nightly feature. Um, at first, when I was looking into this, I actually thought it would be fairly simple. And if you look at the topics here, there's not too much to this. It's just we're going to talk about type aliases, and we're talking about the impl feature, and then we're going to talk about impl in type aliases. So it looks pretty straightforward. But as I dug into this, I actually found that this is a pretty complicated feature. So hopefully this will be actually pretty interesting for people. But yeah, first of all, just going to talk a little bit about type aliases, what they are. This is pretty simple stuff if you've worked with Rust already. And for those who haven't, basically, I think it's like a type def in like C++, from what I've heard from some of my colleagues at work. But uh, essentially, it allows you to define a new name for an existing type. And usually it's used in place of long type names that you don't want to have to keep retyping out. And you can also use them for refactoring. So if you have a type that is used in a lot of different places, and then you don't want to have to update all those places, something you can do is you can replace all those with the with a type alias, and then that way, if you ever want to change the type in all those locations, you can just update the type alias. And yeah, if you're looking to create a completely separate type, type aliases are not what you're looking for. You probably want to use the new type pattern, where you just kind of wrap the type with like a very thin struct wrapper. But anyway, I'm just going to show a very quick example of what type aliases look like in Rust. Let me just boost the size a little bit here so it's a little more visible. So essentially, you define a type alias using this type keyword, and you assign a type to the alias. So here the alias is foo, and we're assigning type u32 to it. That's an unsigned 32-bit integer. And essentially, anywhere where you use foo, you could also use a u32. So here we have a function that takes a foo, and here I've defined two variables, foo and a. One is of type foo, one is of type u32. And as you can see, take foo can take both of those just fine. It just basically treats this as another name for u32. And same if you were to return a foo, it would be basically just another name for u32. No differences there. So super simple stuff. And feel free to interrupt with any questions if you have any. But there'll also be time at the end of the talk for questions as well. So yeah, that's just type aliases. So now we're going to get into the really interesting feature, which is impl. So what exactly is impl? So impl is used to represent a value of some hidden type that implements a trait. And what impl is primarily used for, from what I've seen in Rust code, is it's generally used so you can avoid extra allocations or pointer indirections. So there's a little feature called trait objects in Rust where you can, you've probably seen under like the object-oriented features part of the book, the Rust programming language book. It talks about using like box-dine traits. Those are trait objects, and essentially, impl allows you to kind of do something similar, but not exactly the same. It's like that, but with some limitations. And it allows you to do that a little bit more cheaply, so you don't have to do the box. You don't have to do any of the dynamic dispatch. There's no extra pointer indirections. Impl is also very useful when you have nameless types. Like, for example, when you're working with closures, you can't actually assign a closure to a variable in a let binding. You have to, or like, if you do that, the type is inferred. You can't actually explicitly say what the type of that is because of how closure types work in Rust. Instead, you'd have to use something like impl fun from whatever type to whatever type to describe a closure. So impl is also very useful for that. But as for what exactly impl is actually quite complex. So basically, you don't really need to understand this, or hopefully you don't need to by the end of it. But I think it's kind of important for background, just to explain like what happened with this feature exactly. So impl trait has kind of largely, or at least historically, been thought of as being used to represent existential types. So this is kind of getting into the territory of type theory, which is something that the Rust developers don't really want to have to think about and reason with too much. And this blog post kind of explains kind of how impl trait has been implemented as a quote unquote existential type. And I'll try and explain this very briefly, but if you don't understand it, it's okay. We'll be covering another interpretation of impl trait later that should hopefully be a bit more intuitive. But essentially, you can have universally quantified types and existentially quantified types. And whenever you're working with generics in a function like this, these are usually considered to be universally quantified, these type variables, because you can pass in any type. The type is just chosen by the caller of the function. Whereas in this case, where you're using something like, say, impl trait or like a box-Dyn trait, we would say that, oh, that type is existentially quantified. We have some type. We don't know what that concrete type is, but it implements this particular trait. So that's kind of how impl trait is meant to be used. And they kind of talk about a bunch of things here, such as confusion about impl trait in argument position versus return position. So it turns out that you can use impl trait in a variety of different places, and one of them is in argument position. And it turns out that using impl trait in argument position is roughly equivalent to using like a generic function like this. They're not exactly the same, as I'll cover in a bit. But yeah, this blog post goes into excruciating detail about impl trait and some of the issues with it. But one of the important things to understand about impl trait is that it's actually contextual, and its meaning changes depending on where it's used. So impl trait actually has a pretty rough history. If you look back, a lot of this stuff is kind of buried now, or it's maybe not buried, but it's a little bit harder to find. Like back in 2018, when impl trait was first stabilized, there was actually an RFC made to undo the stabilization of universal impl trait. So when they added impl trait in argument position, they actually created this feature called universal impl trait, and that's this feature here. And a lot of people actually didn't like it. You can see by all the thumbs up on this. Quite a few people didn't agree with this decision, and you can see at the bottom here of the history that Aaron Turon here, he actually took the unusual decision of immediately closing and locking this RFC. So yeah, there was a bit of controversy around at least universal impl trait being added to the language. And you can see like here on Reddit, there was a bunch of discussion as well about this. One of the things that I think people had issue with here is they didn't know that argument position impl trait was going to be stabilized at the time, because the conservative implementation of impl trait in return position was being stabilized at the same time. And it's largely thought that this kind of piggybacked off of that other RFC and got stabilized at the same time. And so it kind of like snuck in, Trojan horse style. And a lot of people were obviously quite upset about that. And you can even see, Aaron Turon from the core team even had to go and like make a statement about this and on this blog post here, addressing this and other controversies about the RFC process and revamping it. I don't actually know what came of this. I didn't look into it. And also, this blog post was actually deleted. So I actually had to use Wayback Machine to find it. I was like, I remember there being something about this way back in the day, back when this was a really hot topic. And yeah, the history is still there. You just kind of have to dig for it now. As for why it was deleted, I have no idea. I'm not going to speculate too much on that. But yeah, there you have it. So Infiltrate kind of has a really messy history, which is why you're going to see, I guess, I don't know, it has what looks kind of like inconsistent behavior, and then they later tried to come up with like a more consistent way of interpreting what it means. But anyway, the way that Infiltrate is used today is essentially on stable Rust. There are two places you can use it. One is in argument position, and one is in return position, and that's pretty much it. In the future, there will be other places where it will be added, and it's actually tracked on this page here. So you can see that it'll be usable in return position in trait impls. This is kind of a pretty big limitation that I think I heard from someone somewhere that this is going to be stabilized soon. I actually don't know if that's true or not, but that would be, it'd be nice to have that. But yeah, there's other places like let bindings, const bindings, etc. And of course, today we're talking about impl and type aliases, and that's the only one in nightly right now. So let's actually look at impl and try and understand how it works, and just get a feel for the feature itself. So here I've created a little playground. So I've defined this trait called myTrait. It has a single method foo that returns a u32, and I implement this trait for a couple of types. I implement for u32 as well as string. And for those who aren't familiar with Rust, yes, you're allowed to implement essentially like you're allowed to implement the equivalent of like a Java interface on external types. The only restriction is that you can't implement a third-party trait for a third-party type. But because I've defined this trait, I can define it for some of the built-in types in Rust. So yeah, so here the implementation of foo for u32 just simply returns 1, and the implementation for string just returns 2. Nothing too special. I just wanted to have some implementations of my trait so I could show off how impl actually behaves. So here's impl in return position, or rpit, as it's referred to commonly in the documentation. So in this case, I'm trying to return something, some value of a type that implements the my trait. And essentially, here I just have this if else here that returns a u32 in both cases. We know it has to be a u32 because my trait is only implemented for either u32 or string. And yeah, that's fine. However, if you try to do something like this, where you, for example, have two different types where you have two different types of values in each branch. This is actually not allowed. So this is one of the key things that you need to understand about impl in return position, is that impl binds to one particular concrete type when used in return position like this. So if I were to do something like, say, box dyn my trait instead, oops, and then I have to actually box these values. If I run this, then this is actually okay. But it's not okay if I just use impl trait. So that's something to be aware of. So there are some differences there. And if we look at impl trait in argument position, we can see that this is the typical way of, or this is how you had to take arguments that implemented a trait back before impl trait argument position was implemented. So it was either this, or you could use like a where clause, where you could be like where a impls my trait, right? But this is just syntactic sugar for this. But impl trait in argument position does roughly the same thing. Now, it isn't exactly the same. So if you do something like this, you can see, like, if I pass in a value 1 like this to both of these, those are both fine. Argument position impl trait is isomorphic to this generic function. However, we can see that they actually are not equal. This is something that Varkor points out in his blog post, is that if you try to use turbofish syntax to explicitly specify what this type argument should be, we'll see that it doesn't actually work when you're using argument position impl trait. So yeah, it's not exactly the same. And that is a slight limitation with this syntax that so many people didn't really like. And yeah, one of the reasons why people didn't like this is because it's so similar to an existing feature already that we have, and so it feels almost redundant. It's just it's like this, but slightly more limited. And the main counter argument against that was, well, we want to make the language easier for people to learn, and they talk about like a dialectical ratchet, and how they want to, show people a syntax that kind of just works the way you expect. So if you're coming from like Java or something, this might be the syntax that you're used to, instead of having to use generics for this sort of thing. Because in Java you can just take an interface, and interfaces are treated as types. Oh, I hear a hand raise, I believe. Do you have a question?
Yeah, I was asking if you get compiled for each type, like generics.
Yes, it would be compiled for each type. It would be just like generics, I believe. There really isn't much difference. The only difference is this turbofish syntax issue. And the reason why that they are like isomorphic and not equal is because impl trait is still existential in this position. It's just that due to some logical rules and the Curry-Howard correspondence, essentially this is, you can translate existentials to universal quantification and vice versa. I don't really want to get too into like those nitty-gritty type theory details, but that's essentially the reason why these behave basically equivalently but aren't actually equivalent. But yeah, this would there wouldn't be any like additional cost to doing this. This is basically the same as this. So that's impl trait in a nutshell. So now we get into impl trait and type aliases, and here I was thinking, oh well, this should be pretty easy, right? But actually no. Actually, as it turns out, it gets even more complex. So what is this feature? Well, it kind of does what it says on the tin, right? It allows impl trait to be used in type aliases. However, as I said earlier, impl trait is contextual. It depends on where you're using impl trait. So that actually has a pretty big impact on how you have to reason with the type alias, because impl trait itself is not really just a type. You have to actually look at where it's used. And so that actually imposes a number of limitations on using impl trait in type aliases. So as we've seen, there's impl trait in argument position, and there's also impl trait in return position, and they kind of behave a bit differently from each other. So the way that this feature works is the type alias defined is supposed to be used like impl trait in return position, and if you try to use a type alias for impl trait in argument position, it will not behave like impl trait in argument position, and that can look really confusing. So another thing is another point I want to raise here is that once you've bound impl trait to a particular concrete type, you can use it in all sorts of other places, or at least you can use the alias in a bunch of other places. So you can use the alias in let bindings. You can use it in your type definitions, like when you're defining structs and such. And because of that, you actually have to be very careful when using it in refactoring. So this is one of the drawbacks that they talk about in this RFC that Varcore made. So in order to try and come up with like a more unified understanding of what impl trait actually is, and to move away from like the type theoretical way of looking at it, we have to understand that impl trait, basically when you have code like this, these types are not necessarily the same type. So you can't just refactor this into a type alias like you might think. It's like this code is not really the same as this code. So one of the criticisms that they point out here is that this kind of breaks referential transparency. So it makes refactoring a little bit weird, or well, refactoring just doesn't work with this. And this is just a drawback of impl trait itself, the way that impl trait is implemented, because it could just bind to different types. It's not like the box dyn trait. It's not like the trait object where the meaning is the same no matter what. This actually has to bind to a particular concrete type. So because we want that extra performance, because we don't want to have to do extra allocations and we don't want to do these extra pointer indirections, we have to pay a cost in that. This feature ends up behaving a little bit weirdly. So I have some experiments here to just kind of demonstrate a little bit more of how this works. So I define an empty trait bar here this time. And here I'm using impl bar in a type alias. So this is essentially how this feature works. And as you can see, if I try to compile this, it compiles fine. But if I try to compile this type alias, this one is not fine. And that's because I'm actually not using foo2 anywhere in this code down here. So that's one thing that you have to look out for, is you actually have to, constrain this to some kind of concrete type. Otherwise, it doesn't know what this type alias is. And so it just says unconstrained opaque type. So here I have some actual implementations of bar. I just created a struct. My struct is an empty struct, so I can implement bar for it. I also implement bar for U32. Here's an example of using the type alias in a struct definition. So this is allowed. I believe you aren't able to do this with a regular impl trait. So this is one thing that the type alias allows you to do. But again, you have to bind foo to some concrete type first anyway. And here is where you can see the differences between argument position impl trait and using this type alias here. So I'm actually just taking an argument of a type foo here, but that's not the same thing as taking an impl bar, right? Because foo is actually referring to a very specific type. And if we want to know what that specific type is, well, we can actually see it down here. This is basically using impl trait in return position. So I'm assigning this variable s to my struct. So this is the constructor for my struct. It's an empty struct, so we don't have to give any arguments or anything. And the compiler will now infer that this type alias refers to a my struct. And so now, in this case, we know that this has to be a my struct as well. So if I uncomment this code that tries to return a U32 instead of a my struct, see, remember U32 also impls bar, right? We'll find that this actually doesn't compile. This is not allowed because we've already bound foo to my struct. We can't rebind it to U32, and that's just basically determined on like the order of the code. But anyway, you don't. It doesn't really matter as long as you have two definitions for or two types that your type alias binds to. Then the code will not compile. So that's something to look out for. And that's also the reason why you're not allowed to do that refactor that I showed in the RFC earlier. However, just because we have bound foo to my struct does not mean that we can just do something like this. So as you can see, this also doesn't compile. And the reason for that is because technically foo is still an opaque type. It's still an impl bar, and it's not actually a my struct. We don't technically know that it's a my struct at this point. And same with this receive foo function. We can't just pass in a my struct here, right? Whereas if we were using impl in argument position, right? If I were to use like impl bar here, and we'll just comment that out for now. We'll see that that's actually fine. So these are actually, we can actually like see that these are different. So if you want to actually use your type alias like this, like you can see here that the code compiles fine, but I'm also doing another let binding. The reason why this works is because get foo returns explicitly a foo. So yeah, you have to actually call something that actually returns explicitly that type alias before it will recognize that, oh, okay, yeah, that is the type of this value, and this is okay. Whereas returning a my struct or just giving it a my struct directly here is not okay. Like this is still technically an opaque type. So I can construct this meow struct that I created earlier using this foo that we get out of get foo, but I cannot construct it out of a regular my struct like this. Like this is not okay. So yeah, that's that's how this feature works. It was pretty weird. I wasn't expecting it to be that weird, but oh yeah, I also made this little Haskell playground. I don't claim to be like a Haskell expert. I just wanted to experiment with this to see like what existentials are actually like in a language that actually supports existential quantification. So here I do something similar. I create a type class called my trait. So this is equivalent to like the Rust trait I had earlier, and I implement it for integer and string. They use for all syntax. This is universal quantification. But again, you can convert universals into existentials and vice versa. So this is actually a existential type. And you can see if I return foo here, yeah, I can do the thing where I return an integer in one branch and I can return a string in the other branch. I tried to do something more like the type alias impl trait, and that doesn't work. So this code builds, but if I try to uncomment this code here, this doesn't build. So yeah, they don't break referential transparency. They don't have this weird impl trait feature that doesn't quite behave like an existential type. They have like proper existential types in Haskell. This is kind of how you would expect it to work. It's basically like box dying trait. I mean, really, that's basically what this is. But yeah, anyway, it's sort of an aside. Just wanted to show a little experiment I did with Haskell. And for those who are wondering, why would I want to use this feature? Well, because maybe you have something like this, like you have this really long name or type name here that uses impl trait, and you don't want to have to like type that out everywhere. You can just give it an alias. But again, like this is probably the only use case for it, or the only real use case for it, I guess, because again, you can't use it for refactoring because of the contextualness of impl trait, right? Depending on where you use it, the meaning changes, and everything kind of breaks. So yeah, it's actually surprisingly more limited in usage than what you might expect. I'm sure people will find interesting things to do with like the opaqueness property for maybe like more niche use cases, but in probably like most production code, you're probably not going to be seeing too much of that. So yeah, this is pretty much the extent of how useful this feature actually kind of ends up being. I guess you can also use this in like structs and lets and stuff like that, but yeah, it's mostly just for like not having to type out so much.
That's a question.
Question?
Yeah.
Yeah, go ahead.
Hi, Jonathan. Thank you so much. My question is that this is the first time I'm joining for Rust. I know Python, but when you showed last function, they were two different methods of defining them, because the way that you defined last two functions that you showed, it was different. I'm wondering whether is there any difference between defining the way of functions in Rust? One of them starts with a break function, and the other was a dash dash or something like that. If you go to the last that you talk about that.
Can you give me an example? Your microphone is the mic quality is not exactly super understandable.
I mean, if you go to the last post that you explained them,
This one?
Yeah. See, you write fn, you mean that function, and iterate, and the way that you define it, and the next one is fn main. There are two different methods of defining function.
Oh, I think she's talking about the return type. So on line 5, you have return type after iterate, but on main, you don't have a return type.
Oh.
Yeah.
Oh, I see. So, sorry, I probably should have explained this too, for those who are really new to Rust. This is
Thank you.
syntactic sugar for this. This is called a unit type. The unit type kind of behaves like void in other languages like Java. It's a little bit different semantically because it makes things a little bit nicer in a lot of ways. Like in Java, you'll see like they have callables and runnables and a bunch of different methods where it's like, oh, this version returns void and the other version actually returns a payload. By having this unit type in Rust, we don't have to have all this like code duplication. We don't have to create like two different types of like runnables or whatever. We don't have to have like a version of the function that returns void and a version that returns a payload, essentially. But yeah, that's why this function doesn't have a return type on it. This one doesn't explicitly technically return anything, but it actually returns a unit.
You have another question as well from Ivan.
Oh, go ahead.
I just wanted to extend, if you can stay on the code, please. I want to talk about the use case for not necessarily the type aliasing for the impl traits, but for actual return position.
Sure.
So again, going back to the difference between boxed dynamic and impl trait in return position, the main difference is that you're getting concrete type, as we've discovered. So it's more similar to using the, so basically you're not getting the fat pointer, right? Because when you have the thin trait returned, you get a fat pointer, which is double word for the location of the data. So basically the type which implements the method, and then the method itself. So you have fat pointer, where here with the type alias in return position, you're getting single word pointer to the concrete implementation. So this is the same as generic, but as you've shown, this has also the limitations of generics where you get single implementation for the same function, right? So you cannot implement it for multiple types in parallel. And obviously, type aliasing here is for better look, because if you will use it all over the place, you will have more readable code. But there is actual use case for this, when you don't want to have a double, so basically fat pointer, and consume more stack for that. And that's where the performance benefit comes from, when you use infiltrate in return position.
Yeah, no, yeah, that's what I was talking about earlier when I was saying it's more limited than the box dine trait. Like it's more limited than using the trait objects. But yeah, you're right. So we could have instead used like a box dine iterator here, and that would have done an extra allocation and stuff, and that would have been easier to work with. We would be able to do like the refactoring and stuff. But in this case, because we want to avoid that extra allocation and dynamic dispatch, we can use impl instead. Like, we don't have to use this type alias at all. We could just put impl in here, but then everywhere where we would want to use this type, we would have to, write it all out, and it's pretty long. So that's the main reason for using the type alias. It's when you've already committed to using impl instead of a box dine trait or any other kind of dynamic dispatch. You can also do dynamic dispatch without using boxing, actually. It works with regular references, and I think also mutable references as well. It just needs some kind of pointer. But yeah, this is, you more commonly will see it with like a box, which implies, yeah, the fat pointer. So yeah, that's basically all that I had to talk about today. As for why this isn't stable, there's one outstanding unresolved question that the Lang team still needs to address. They also have to adjust documentation and create like the stabilization PR, but otherwise this feature seems like it's mostly complete. And I think if there was like a serious push to get this finished, I think they would be able to stabilize it pretty quickly once they answer that one question. But yeah, who knows when that'll happen. I don't know if that's a priority right now or not. I kind of doubt it is. So yeah, now is a good time for questions if there are any further questions. I also have some extra links here for people who want to read up on some of this stuff. So obviously I have Varkor's blog post that explains existential types in Rust. And there's this, this is not a Rust post, but it's an explanation of universal and existential quantification in types, at least with respect to Haskell, which is obviously the inspiration for this feature in Rust. And there's no other better source for understanding impl and type aliases than the actual RFC itself. So yeah, there's also a link to that here too. But otherwise, yeah, I'm taking any questions that anyone might have at this point, but I think we've already gone through quite a few questions, so I don't know if anyone has any others.
I appreciate if you share the link. Those links. Yeah, thank you.
Yeah, I can share these. I will also be I'll also be posting the slides up later, so you don't have to worry about that. All the links should be available in the slides once those are up. And the recording for this meetup will also be posted probably this weekend as well. All right, there we go. Phew. But yeah, those are the links if you want to look at them. They go into excruciating detail about stuff that probably isn't even all that relevant to this version of impl, but hey. All right, Logan.
Hey, thanks for the presentations. Cool feature. I'm wondering, does it have like the same rules as other impl trait things where you can like plus multiple traits together with some limitations? Like you can do like auto traits like send and sync, but if you want to combine like, you know, two arbitrary traits, you have to make like a trait that like inherits from both of them. How does it play with?
That's a good question. I actually don't know. We can try it though. Yeah, I don't typically use impl in argument position, so. Or I don't know if it works like that in return position either. I think you might have to make a subtrait that, yeah, I think you might have to do the subtrait. We can do this really quickly.
Sort of a side question while we're doing this is how does this relate to lifetimes? Because like a lot of times in impl and return position, like if you have an iterator that's like capturing something by reference, you have to like do a plus tick underscore to be like, yeah, it's capturing, you know, the anonymous lifetime. I'm curious how that would factor into this.
Plus lifetime, like what do you mean?
Yeah, I guess it's kind of a separate question, but you know, sometimes when I'm returning like impl iterator, like my iterator inside the function body is maybe like referencing one of my function parameters that I'm taking by reference, and so the thing I'm returning is also constrained by the lifetime of my parameter.
Oh, like, oh, okay, I see. Like sometimes you might have like something like this, I guess.
Actually, like at the top level, like so, like right before the semicolon. I'm curious.
Oh,
Sometimes in my function signatures, I'll do like plus tick a right there or something, because like the whole iterator is bound by that lifetime. But I guess I'm not sure how that would work with this. That might be like kind of just an esoteric.
Honestly, I'm not familiar with this syntax.
Cool.
I didn't know about this plus tick a outside of the
Yeah, cool.
That
Maybe
depends if you have stuff attached to some struct and that struct has some references to something, right? Because if you don't have any external limitations on the lifetimes, they just get assumed by compiler, right? Because you, again, if it's internal and item is a reference to something and you return it from function, which is like free function, you will get compiler shouting at you that that won't fly because the data is owned by function which is exiting the scope. Yeah, but if you have a method which attached to something with a lifetime, and you say that yes, this iterator will live as long as this struct, then it will work.
Yeah.
Yeah, I'm not really sure how that all works, unfortunately. I don't know. Maybe that has something more to do with like generic associated types, but
yeah, sorry for overcomplicating it. I am curious about the foo and bar thing though. If we can just do like impl foo plus bar, I think this works. I'm curious if it works in the type alias too.
that's a great question.
Maybe this doesn't work. Maybe I'm misremembering.
Oh, hang on. Is that okay? Oh, I have this lifetime up here. Looks like it's fine. Yeah.
And so then, yeah, I presume you could just do that same thing, like impl foo plus bar up in the type alias to say that like this opaque type implements both of these traits.
Yeah, probably. We could try that. Of course, now that complicates things because now, well, that's different from this because that's in argent position. So now we'd have to do it here, and okay, I'll delete this. I can delete that too. So this needs to return something that implements both of those. Okay. Well, we have what? We have a U32. We could just do that. Actually, no, that one. Oh, right. You can do that.
Cool.
Okay. Yeah, that seems to work. Yeah.
Cool. Thanks for humoring me. Yeah, this seems really useful for sometimes, yeah, you're returning this big complicated iterator from a function, and then like you want to store it somewhere. You don't necessarily want to run it right now. You want to store it in a struct or a vec or something. And like there's kind of no easy way to do that without boxing it up at the moment.
Yeah.
This seems like it would be a really good way to avoid that.
Yeah, but now the question is if it will work if it's not just a market trade, right? If there is actually some method in each of them, will that work
true.
or not?
Yeah,
But
that's
you
true.
have two market trades which basically do nothing, and when you do release build, you will get just constant one in your binary, and all of that will be optimized out. So this is not guaranteed to work. So I'm not sure.
All right. I mean, we can entertain that too. Frick. Let's return something here. Oops, I don't know what I'm doing. Why am I doing this? And you can return 2 and give you, I don't know.
You know what? Leave the default implementation here. We will see if that works as well.
Oh, you want to see the default impl as well? Okay, sure. We'll give this one a default impl. Okay, and then we can just do that, I guess, for both of those. So what do you want me to test exactly? Just returning this and then what, calling like .move on that, or because I can do that. That seems fine. And it's the variable. We also call what's the other method I call? Blah. Blah. Yeah, that seems to work.
Please. Copy that print line and try both. Maybe on the same object, store foo in some.
Oh, you want me to store foo in a variable?
Yeah, and call them both on the same object.
Oh, okay, I see.
No need to declare it as foo, right? Just let something and then call foo.
Oh, yeah. You want me to just leave off this entirely?
Yeah. Let's see.
Let it infer it. Okay, sure. Let's do it. Why not? Why the heck not? Oops, sorry, wrong.
Perfect. So it definitely works.
Yeah. I mean, maybe I downplayed the usefulness of it. I mean, obviously it's pretty useful, but like it still breaks referential transparency, so you can't use it for like refactors and expect that it'll be, it'll just work the way that a regular type alias does. But yes, I do still think that it has value. And personally, I think there's more value in impl trait impls, because right now trait impls can't even return an impl trait at all, which sucks. But this is also pretty cool too. Anyway, do we have any other questions? I see Peter posted the infiltrate initiative. Yeah, this is the sounds like the explainer with all the different places where you can use infiltrate and whatnot. Yeah, I was actually digging into infiltrate primarily because I wanted to learn more about existential types. I had a use case for existentials, or more specifically using rank n types, but it turns out that this feature didn't really do what I wanted. Another feature does, but that one also is not. It's not even in nightly. It's like it produces internal compiler errors whenever I try to use it. So yeah, I'll talk about that another time though when I talk about my project. Yeah, if anyone has any other questions or comments, feel free to ask right now. Otherwise,
I
forever
have
hold
a
your.
general question.
Oh, go ahead.
Thank you so much for those really enjoyable presentation. I work with the MATLAB, Python, C++. I'm wondering if you can explain in short how Rust has connection with those programming or how it would be useful for me, because I'm really interested to learn Rust. But I'm wondering if you a little guide me that how it could be useful, what is the bonus and positive points of Rust, how it can be better. I don't know, a little compared with other language. I'm curious
Just
to know how this session can be helped and guide me, because this session I just get familiar with that and I need to practice. I need some reasons to be motivated to do that.
okay. If you want just general advice on like what Rust does, I guess, better than other languages, or why
Uh-huh.
it's good to learn Rust, then I can answer that. If it's for like your specific use case, I don't have enough domain knowledge to really say. Someone posted the Polars package, by the way, in case you want to take a look at that. But in general, I mean, Rust is a much faster language because it gives you a little bit more control over memory. Like you're playing with references, obviously. A lot of libraries also use raw pointers and stuff. Safety compared to C and C++ is a lot more controlled. You have like these unsafe blocks that you can use to like kind of demarcate like where stuff that could potentially cause memory vulnerabilities to happen might stem from what else. The type system in Rust is kind of the star of the show, really. Obviously, Rust doesn't feature any kind of like runtime garbage collector. It doesn't have like a mark and sweep stop the world garbage collector like some languages do. So in general, you're not going to have to wait for any kind of like pauses like that. It's ahead of time compiled, so it's optimized. The Rust compiler is an optimizing compiler, so you can write fairly high level code and it'll optimize it really well with zero cost or they call them zero cost abstractions. It's really more like zero overhead abstractions. So you don't have to like pay more than for what you use. And because Rust type system is so strong, it's learned a lot from other languages. It doesn't fall into a lot of the pitfalls that other languages do. Like, for example, Rust's null safety is very good. It avoids, a lot of the problems that other languages like Java have, where you can set pretty much every reference type to null, and then you get null pointer exceptions and stuff. Basically, the $1 billion mistake talk. I think by like Tony Hoare talks about that a little bit more, but a lot of modern languages these days have like nullable types, and Rust has something similar with its option type.
Awesome.
Yeah, I could go on. I would say definitely if you want to learn Rust, start with the Rust programming language book. That's the free book that they recommend you to start with when you go to the Rust homepage, when you download and install the compiler. Because a lot of the reasoning for features in Rust is there.
Yes, sir.
It really feels like a more modernized language, and you don't have as many pitfalls as like when you're trying to write code in C or C++, which are the traditionally considered fast languages. Okay, someone's recommending to do Rustlings as well. Yeah, there's a bunch of different tutorials you can try. I know there's also like Tour of Rust as well. Everyone's gonna have different opinions on what's good. So
Thank you so much. I got the answer.
go ahead, Ivan. Or did you not want to raise
sorry,
hand?
misclicked.
Misclick. That's fine. Any other questions? Going once. Going twice. Okay. Cool. Yeah, that's it for today. I don't really have anything else to really talk about. Like I said earlier, I'm, trying to get, an office space for us. Hoping that our office reopens at some point once renovations are done. Hopefully sooner rather than later. But yeah, it's just taking longer than every single estimate that I've ever been given. So I really don't know. I really don't know when it'll happen. I would really like for it to happen, but yeah. And again, for those who are new here, the plan is to shift to hybrid events. So for those who are joining remotely today, don't worry, there will still be a place for you. You'll still be able to join. I'm yeah, learning Rust will make you learn how to hate Python in a way. I do agree with that.
Not really. I mean, there are strengths for both of them. If you're working on backend and you're dealing with WASM, so you're getting into the blockchain stuff, Rust is a way to go. Go now also has the compile to WASM. Python doesn't have that, and it's not going to go to that. So Python is good for a lot of things. And it really depends on your use case. It's the classical example answer. It depends.
That's true. Yeah, there's still definitely places for Python. You're gonna definitely want to leverage its ecosystem for certain use cases, or like, I don't know, running Python in Lambdas is a little bit better because you don't have to like compile everywhere, like when you have to run Java on Lambdas. So there's definitely, there's uses for like interpreted languages like Python for sure, but I really like having a strong type system.
Me
I
too.
I wish more
It makes
languages
a difference.
Yeah.
But Python, the newer versions of Python are having that. In the past, I had to run MyPy in order to ensure that our code development has the data types and the safety there. Nowadays, the newer versions of Python 3.11, 3.12, it already has that built in.
Yeah, I've seen Python's like type hints. They didn't seem like they provided as much expressivity in the type system as Rust's type system does. But again, I also am not a Python expert, so I'm not going to talk too much about Python. Actually, every time I mention Python, I know that there's like a swarm of people on the YouTube comments who are just going to try and like get angry at me. So
no, there's no getting angry. I mean, you're absolutely right. It's nowhere strict as Go or Rust. You can still introduce breaking changes and somehow screw up the typing. With Rust, it's the compiler.
Yeah, I'm just saying that Python is very, very popular, and it's kind of a hornet's nest. I don't really want to be poking too much, because last time I uploaded a talk that someone did that had Python in the title, there was like a bunch of people from like the Python community who are not very happy. They're like, "Oh yeah, but you can't you can't be as productive in Rust as in Python and stuff," and blah blah blah. Or like, "Yeah, fat chance, haha." So I don't know. I don't I don't want to stir the hornet's nest, but I think I probably already.
No. There's no need to do that, but I think it's Razi, she raised a good question, especially if you haven't worked with a lot of programming languages in different contexts. That can happen to a lot of us because we get stuck in one context and we don't see anything else.
That's true.
Cool. Thank you very much.
Yeah, no problem. Yay, thank you for all the applause. I'm just doing my best out here trying to turn out talks for y'all, because well, partly because I'm somewhat obligated to do it, but also it's just nice to kind of get back into a rhythm of learning more about Rust and playing around with the language more. So I think next month the plan is for Chester to do a talk. I don't know what the topic is. I think Chester, you wanted to poll people on that.
Yeah, I kind of wanted to get people's feedback on what they would be interested in me talking about, because I'm interested in all the topics that I have. So I'm working on a project for school, and it's built in eGUI. And I don't know, it's been an interesting project, and there's lots of things I could show on that. Like I had to set up some caching for some somewhat expensive operations that had to run each frame. So that was easier than expected. Then I also planned to do, well, I was planning to Advent of Code, but Shuttle is having a Christmas code hunt, so I'm planning to do that instead, because they said it's going to be easy, and you know, I'm kind of short for time right now, so yeah, easy sounds good. Take less time, because Advent of Code has a reputation of being challenging. And then I also need to write a bot in Rust, so you know, I think it'd be a good push if I have to do a talk on it to actually finish the bot. So if people are interested in that, then I can do a talk on that. That was the ideas I had.
Which bot? What platform for? Because I did the Discord bot like 2 weeks ago. It was super fun. Took me like 2 days.
Yeah, so right now, of all the use cases I still have left, only one I have left is reminders. So the functionality I'm still missing is reminders. So you can schedule events, and then it'll tell you, hey, your event's coming up X hours from now, kind of thing. Because sometimes I have meetings, and you know, I don't forget them because they're on my calendar, but everybody else forgets, and then I show up to the meeting and nobody else comes. I'm like, what's happened, guys? Oh, do you want me to send a reminder? I'm like, you know, I can't send a reminder every time. So that's one use case I have still that I still need a bot for. And then I also need a bot to communicate with my monitoring server, because it sends out notifications when things go down, but it's a one-way communication right now. So it sends messages to Discord via webhooks, but I would like a way I can send a response and say, okay, I know this thing is not working. Stop telling me now, please. So yeah, that's why I need a bot. You were saying that you made a bot already. What does your bot do, if you mind me asking?
It's a game So basically, I can share the invite if you guys are interested, and I can publish the source code for it. So
Or maybe you
basically,
could just
it's
talk about
yeah, I can. That's kind of fun part
Yeah.
of writing something for yourself.
Right.
I had like when I was in university, we had an IRC server, and there was this game bot also. So basically, it provides the description of a word from a dictionary, and who guesses the word first gets points. Yeah, so
Right.
that's the similar bot.
Well, I mean, the interesting part for me and would be to see how you made the bot and that kind of thing. So if you want to do the talk, I'd be happy to watch that talk. 'Cause I'm more interested in that than in my talks.
No, let's keep it intern.
Sure.
Yeah, I mean, if anyone wants to do a talk, feel free to message me or message Chester, and we can schedule you in. You can talk about whatever you want, as long as it's related to Rust, in some way. Then it should be fine. But yeah, do let us know. We are, always looking for people to participate and pitch in, do talks. I personally really like doing talks because it helps me learn things. It kind of forces me to actually like look into certain things with enough depth that I can actually feel confident in explaining it, and it forces me to kind of know what I'm talking about, I guess. But also, doing these talks also broadens my horizons because there's a bunch of features in the Rust compiler and other things that I just never look at otherwise, and it kind of gives me an excuse to learn about things that I normally wouldn't spend the time to learn about. So yeah, I personally find it quite rewarding, but yeah, up to you.
So between those three ideas, which one are people most interested in seeing next month? Ivan's talk on the bot, or Christmas code hunt from Shuttle, or that I'm building for school?
I always like to hear about people's actual, like, real projects, school work, or kind of like hearing about the real uses
Actual
for
project.
Yeah,
Okay.
yeah. I find that interesting.
Okay. There are no other votes, and I guess that would be it because that's the only vote.
All right.
All right, so be it. So
there you go. There's your vote.
I'll try to come up with a name for the talk, and I will present the talk on what I've done for school for the GUI builder thing, data set builder. Hopefully, in that time, I can actually add on some more functionality, so it'll be more interesting.
Cool.
That's a very interesting GitHub username.
That's my ICQ number. I don't know. I'm probably too old, and people, when I say this, don't have any clue what ICQ is. But
Oh, I was on ICQ.
Me too. We know what ICQ is.
I'm gonna Google it.
There's your rage right there. I need to Google that.
yeah, and I think ICQ source code is also open source now, so you can even look into what we were running.
Nope, never heard of it. And manage a pigeon, I guess. There's instant messaging and VoIP.
So I'm just looking at the code. I noticed that you're using extern crate still. I think that's, I wouldn't say deprecated, but you don't have to use that in more recent editions of Rust.
I guess that's just a muscle memory, mate.
Were you around in like 2014 2016 when Rust first stabilized, or like are you an old school user?
I have few repos back from 2015 of
Oh,
Rust,
okay.
and I like to reminisce on that code. I remember when I first used map on iterator, and it was like, I don't know, 3 gazillion% faster than for each loop. I had no particular clue what it was doing under the hood. When I first used it, I was like really amazed by someone did this. Like I just provide closure and it works on my data. So yeah, I think if you look for a big data repo, it's really like rusty and old code written back in 2015. But yeah,
That's really cool.
I remember. I remember.
Do you remember back when trait objects didn't require the dying keyword?
Haven't used that at the time. I do remember seeing that in few places, but I didn't have any use case for that. So yeah, and I think
There was no dying keyword, so
and, yeah, and there was no limitations for the trait objects, right? We have 4 limitations right now, and there was nothing, or there were some. Yeah, there was a wild time that you can put in anything and it will just try to resolve from the table. Yeah.
I wasn't around during that time. I started writing Rust in like 2016, so like a year after stabilization. And by that time, I think they already had that in place, but they still didn't have the dying keyword. And it's interesting to see like why they added it. Like it doesn't change anything at all. It doesn't even like disambiguate, because it was already unambiguous without the dying keyword, but it's just like, oh, this makes it easier for people to learn that, you know, you can't really treat a trait as like a type. It's not really the same thing. And it's just supposed to be there to help people like understand the language. I don't know. It's kind of interesting. And you still see places where they use trait objects without dying. Like I think the static assert library, like deep inside some of those procedural or annoying procedural, like some of the declarative macros they have, I think they still do that, which is pretty interesting to see. Just a little bit of history for everyone who didn't know about this. But yeah, there was a time you didn't need to use the dying keyword at all.
Yeah, I learned that from Neurostation.
Oh, you learned that from Neurostation? Dang, spoilers.
Yeah. That's before I started using Rust.
Oh, okay. Now, is there anything else that anyone else wants to chat about? Any questions or comments or concerns? It can be about whatever you want at this point. Otherwise, I'll just kill the recording and we'll just move on with our days.
Yeah, we can kill the recording. I have some boring thing that I thought of as you were sharing that I wanted to share.
All right, let me just kill the recording now.